This is Advanced Math, Unit 10, Lesson 4. Sketching rational functions. And today we're only focusing on bottom heavy and same degree. Bottom heavy and same degree. The top heavy graphs we'll be doing tomorrow. So for today it's sketching rational functions, bottom heavy and same degree. All right, number 1, y equals x plus 2 over the quantity of x plus 3, x minus 3. All right, and we are sketching these. And we're going to do the same thing we did yesterday. D for domain, VA for vertical asymptote, HA for horizontal, x-intercepts, y-intercept. So we're adding these two. We've found these before, but we haven't put them all together. Okay, domain, we've done that before. It's all reals except for what would make the bottom 0. So all reals such that x cannot equal -3 and +3. And there's no reducing, so I go on to vertical asymptotes. When we're vertical asymptotes, we look at what makes the bottom 0. And there's two different values, and we make two separate equations. X equals -3 and x equals +3. We do want to now look at the multiplicity of where these came from. X equals -3 is coming from there. X equals 3 is coming from this one, and they both have a multiplicity of 1, which is odd. I'm just going to put a little m equals 1 on both of them. M equals 1 for multiplicity, which is odd. The reason I'm doing that is because we're going to come back to that in just a little bit. For now, just write it and recognize that these two came from the denominator, and both of them had a multiplicity of 1. All right, remember horizontal, we take the limit as x approaches infinity. And since it is the same, since it is bottom heavy, 1x at the top and there's a degree of 2 at the bottom, it is 0. And don't forget the y equals 0. X-intercepts, you take the equation, make it equal to 0. 0 equals x plus 2 over x plus 3 times x minus 3. I'll let you guys solve that on your own. You clear it by multiplying both sides by the denominator, remembering that's going to clear the denominator, leaving that behind. 0 equals x plus 2 means x equals -2 is an x-intercept. Paying attention to the multiplicity, because the cross and bounce stuff we're still working with. X plus 2, there's no power there. It only occurs once. The multiplicity is 1, which means it's odd, which means it is a cross. I'm going to put a little note there. When we graph it, it's not going to bounce, it's going to cross. Y-intercept, I plug in zeros for all my x's. So I have 0 plus 2 over 3 times -3. So my answer is -2/9. Okay. I'm going to erase that x equals and just leave it as a -2. X-intercepts -2, y-intercepts -2/9. All right, let's go ahead and try to graph this. And it may seem a little confusing in notes. Remember, when we start doing work together in class, it typically makes a little more sense. All right. Okay, now we're going to start to plot and label some of our stuff. we have, we don't plot the domain, that's just telling us what our domain is and whether we have a hole in our graph or not. But we are going to graph the vertical asymptotes. I have one at +3 and one at -3. 1, 2, 3. That's an asymptote. Asymptotes are dotted lines. Now this dotted line is not a part of my graph. It's just guiding me when I'm graphing. I know I can't touch this area. If you were to plug this into a graphing calculator, these dotted lines would not come out, or into a computer program that graphs for you. Again, those dotted lines do not come out. That's just for us to help guide us when we are graphing. Okay, horizontal asymptote of y equals 0. Now it's a little harder to see, but y equals 0 is the actual x-axis, so this is my horizontal asymptote here. Now remember, we never touch or cross our asymptotes, and that is still true. The only thing is the horizontal asymptote, you will touch or cross only if needed, if necessary. These here you'll never touch or cross. The vertical ones you're never going to touch or cross, but the horizontal you will only cross if necessary, and I'll show you what I mean in just a little bit. Okay, so let's go ahead and continue. Plot your y-intercept. My y-intercept is -2/9, which is smaller than 1. Someone just put it in here. My x-intercept is -2. Put it here. And that's all I really have. I don't have anything else to know, to guide me on what's going on. But I know I have 3 sections of my graph. I have the left, the middle, and the right. Okay, so what you do is you pick a value to the left. I know my graph, since there's no x-intercepts over here. Do you see that? There's no x-intercepts. I know my graph is going to be either all at the top or all at the bottom. And I know that because there's an asymptote, and I have no reason to cross this horizontal asymptote. There's no x-intercepts there. So I'm either all at the top or all at the bottom. And we don't know where we're at, so we pick a value to the left of this asymptote. 1, 2, 3, -4 would work. What else would work? -5, -6. And all we're going to check to see if it's positive or negative. If it's positive, it's in the top half. If it's negative, it's in the bottom half. And we plug it in there. All I care about is whether it's positive or negative. So we're going to do kind of what we did with our test values. When you plug it in at the top, -4 + 2 is negative. -4 + 3 is negative. -4 - 3 is negative. And 3 negatives is going to make a negative. Which means if I were to plug in -4, 1, 2, 3, 4, I'd get a negative answer, which means I'm on the bottom half. Which means the whole graph is on the bottom half for this far left piece. There is no graph at the top because I have no reason to cross that asymptote. So I have that piece done. Okay, this next piece is a little tricky, so I'm going to write it down here, how to, what your vertical asymptotes do for you. Vertical asymptotes. If the multiplicity is odd, it's going in opposite directions. Just write it down for now, I will explain. Okay, if your vertical asymptote, if the multiplicity is even, it is going in the same direction. Okay, so what this means, I'm just going to show you some graphs really quick. This here is a vertical asymptote. This is going opposite directions. Do you see how this one on the left side is going up and this one's on the right side is going down? Where this one down here is going in the same direction. They're both from both sides going up, or they could be going down depending on the graph. So that would be same direction. Here's another example of opposite. This one's going down on the left and up on the right. Okay, so that's what I mean by same and opposite. Now, remember when I told you earlier to label your multiplicity, that was y. Vertical asymptotes, that's here, come from the denominator. The multiplicity for both of them were 1, which means they were both odd. Put a little note of odd here. If they were 2 or 4, I'd put a little even note. Okay, what this tells me is that on this inner piece here, I'm going to start from the top. I'm not starting from down here because that would be coming from the same direction. And according to odd, it's opposite direction. So I'm coming here. I have this x-intercept to cross, not bounce. I have the y-intercept to go through. Now, after I get here, there's no x-intercepts here. There's nothing bringing me back up. If there were an x-intercept, I would cross it or bounce it depending and continue. But since there's no x-intercepts, I'm not going to cross that, and I'm just going to continue going towards my asymptotes, which is what the graphs always do. They go towards the asymptotes. All right, so here's an example of a time you cross the horizontal asymptote. You only cross it if necessary. If there's an x-intercept and it's a cross, not a bounce, or even a bounce, you would touch it. So there's an example. These you never touch or cross. Horizontal only if necessary, and this was a necessary situation. All right, odd means opposite direction, so I'm not coming from the bottom, I'm coming from the top. And again, I always approach the asymptote, so it looks like that. That there is my final graph. Okay, number 2, hopefully these will go a little quicker now that I've done all the explaining. 3 over x plus 1, y equals 3 over x plus 1, D for domain, VA for vertical asymptote, HA for horizontal asymptote, x-intercept, or intercepts depending, and then y-intercept. Okay. Domain, all reals, such that x cannot equal -1 because that makes the fraction undefined. Vertical asymptote comes from the denominator, which also helps me figure out this odd-even stuff. The only thing in the denominator is the x plus 1, which means x equals -1. And the multiplicity here is 1, which means it's odd. Horizontal asymptote, I take the limit. It's bottom heavy, which means y equals 0. X-intercepts, I set the equation equal to 0. 0 equals 3 over x plus 1. When I multiply both sides by x plus 1, this is gone, leaving behind 0 equals 3. 0 by itself, or 3 by itself, cannot equal 3. I'm sorry, 3 by itself cannot equal 0. So there are no x-intercepts. Y-intercept, you plug in 0, so you have y equals 3 over 0 plus 1, which is 3. Okay, let's try to graph this. All right, so we're going to do our horizontal, vertical, sorry, x equals -1. Horizontal is again y equals 0, which means the x-axis. It's a little harder to see, but it's there. And my x-intercepts, there are none. And my y-intercept is 3. 1, 2, and 3. Okay, so some kids will figure out like, oh, I can tell I'm going to be starting down here because I know I'm going to be up here at the end because odd is opposite direction. That made no sense. I'll explain in a little bit. Odd because my vertical asymptote, this -1 came from x plus 1. The degree is 1, which is odd. Okay, so pick a value to the left because we don't know if we're at the top half or bottom half. I'm going to pick -2. You can pick any value to the left, -3, -4. Y equals the positive number over -2 plus 1 is a negative number, which equals a negative number. So we're at the bottom half. Opposite direction, because that's odd, means I'm coming from up here. I have this intercept to hit, and I have no x-intercepts at all. So I'm just going to approach the asymptote like that. And there's the graph. Again, if it seems a little confusing, I will explain more in class when we do some together. So what I was saying is some kids will figure, well, if this is up here and it's odd, I know this piece is going to be down here. I don't have to do a test value. If you can figure that out, that is perfectly fine. Okay, number 3. Y equals 2x plus 1 over x plus 3. D va ha x-intercept, y-intercept. Okay, there's nothing to factor, so domain is all real such that x cannot equal -3 because that's what makes the bottom 0. Vertical asymptotes come from the denominator, and that tells me opposite direction, same direction, so I look at the degree, it's 1. So x equals -3 and odd, not because of the 3, it's odd because the power is 1. Horizontal, y equals, it is the same, this one's the same, it's not bottom heavy, so I do 2 over 1, which is 2. Now, since a horizontal asymptote is 2, not 0, we no longer have to do those test values. I'm going to flip it over really quick. We only have to do these test values when our horizontal is at 0. That's the only time. We don't have to do it when our horizontal is at 2 or 3, or if we have a slant asymptote, which will be another lesson, we don't have to do those test values. Okay, x-intercepts, make the equation equal to 0. You don't even have to write the bottom because when you multiply the both sides by x plus 3, it's going to cancel it out. Solve that, subtract 1, divide by 2, the multiplicity is 1. So my x-intercept is -1/2. 1 means cross when you are graphing x-intercepts. Y-intercept, I plug in 0. 1 over 3, 1/3. Okay, let's graph. All right, so vertical asymptote is -3. Horizontal is y equals 2. Okay, and I still have, really quick, I'm going to flip it again. This one I had 3 sections, the left, the middle, and the right. Do you see that? 3 sections of my graph. This one I only had 2, the left and the right, depending on how many asymptotes you have. This one only has a left and a right. It's not cut up in 3 sections. Okay, so apply my x-intercepts, -1/2. I'm going to switch that spacing out just a smidge. So -1/2 is there. Y-intercept is +1/3, which is less than 1. Okay, so here's why we don't need to do test values, because my horizontal's no longer on the x-axis, I can use x-intercepts as a guide, and here is what I mean. Left half, I'm either top or bottom, and this time top is this top corner above the y equals 2, or the bottom, which is below the y equals 2. So it's either all in the top corner or all in the bottom corner. And the reason I don't have to use test values is because there's no x-intercepts over here. And because there's no x-intercepts, that means I'm all at the top. If I try to put it at the bottom, do you see that it would give me an x-intercept, which I don't have, which means I have to be all at the top. Again, we'll do more of these in class. Okay, vertical asymptote, we said it was odd, and it's odd because the multiplicity was 1, which means opposite direction, which makes sense because I have these intercepts down here, which means I'm going like this. I have that to cross, that one to cross, and then I always approach the asymptotes, and there's no other intercepts bringing me down over here, so I approach it on that end, and they are going in opposite directions. Number 4, y equals x plus 1 squared, x minus 2, over x plus 3 squared, x minus 4 cubed. All right, I am going to have you try this one on your own. Let's at least write this stuff down. D, va, ha, x-intercept, y-intercept. Now keep in mind right here, right there, we have some multiplicity that's even, which means there are going to be some same direction, opposite direction. I know that may sound a little confusing. Try your hardest, do your best. We will go over it together in class.